Hi everyone and welcome. Now let's quickly revise what we've learned so far before we get to today's example. Now if we are given the following, and here you can see it's a line from the center that is perpendicular on a chord, what do we know from this? Well, we know that this part of the chord is equal to that part of the chord. In other words, the chord will be bisected. So we can say this is equal to this because line from the center is perpendicular to chord. We use this theorem because that is what was given. Okay, now here's our next diagram. What if we are given all of this? So we're given a line from the center and it bisects the chord. What do we know now? We know that this angle will be 90 and that angle will be 90. And we use line from center to midpoint of chord. Why do we use this abbreviation? Because that is what was given to prove that these angles are 90. Now, here's the next one. When we are given an angle at the center, and we know this is the center, and we're given an angle on the circumference, well, we know that if this was 60, this angle on the circumference will be 30. Okay, now why? Because the angle at the center is equal to 2 times the angle at the circumference. And it's easy to see. Can you see that this angle here at the center is much wider than this angle here on the circumference? Now, it's actually this one at the center is 2 times wider than this one on the circumference. Now, what if they look like this? Well, if we have this angle at the center, but this angle is not on the circumference, but they're still subtended by the same arc or chord, well, this theorem doesn't exist because this angle has to be on the circumference and this one has to be at the center. Now, how about this one? We are given this angle and this one on the circumference and both are subtended by the same arc or chord. Now, this is quite easy too. We cannot use the theorem because this angle is not at the center. Got it? So we have to have an angle at the center, we have to have the angle on the circumference, and both angles has to be subtended by the same arc or chord. Got it? Now let's go and look at an example. Now here is our diagram, and no, it's not as daunting as it looks. Let me show you. O is the midpoint of the big circle, and ABCD is on the circumference of the big circle, and BODE is on the circumference of the small circle. Now let me show you what all of this means. Well, this point here is point O, and they said that this is the midpoint of our bigger circle, and it's very important to know that. Then they say that A, B, D, and C is on the circumference of the big circle, and B, E, D, and O is on the circumference of the smaller circle. Now, let's look at an example. Let's assume that this angle here, O1, is 2x. Okay, so now let me show you quickly. There it is. So that means that this A1 is going to be x because this side and this side and this side and this side that makes these two angles are subtended by the same arc CD. Okay, so now we can write A1 is equal to x because we take the angle at the midpoint, we divide it by 2 and we get the angle on the circumference. So A1 is equal to x, and our reason is angle at center is equal to 2 times the angle at the circumference. Now I'll show you the following. There we go. And now you can also see that B1 will also be x because this is the angle on the circumference, this is our angle at our center, and they are both subtended by the same arc CD. So B1 is equal to x, and our reason is angle at center is equal to 2 times the angle at the circumference. Now let's say we want to find the size of angle O2. Now that's quite easy because these two angles are on this straight line CB and they are divided by this line OD. So both these two angles must be 180. So that means that O2 is equal to 180 degrees minus 2x, and we will say angles on a straight line. Now look very closely at our diagram. And there we go. Can you see it? So A2 is the angle on the circumference. This is the angle at the center. And remember, the angle at the center is 2 times the size of the angle on the circumference. So to get A2, we're simply going to take this 180 degrees minus 2x, and we're going to divide it by 2, and we get that A2 is equal to 90 degrees minus x. Now, we can use angle at center is equal to 2 times the angle at the circumference, because this is the angle on the circumference, this is the angle at the center, and they are subtended by this chord BD or this arc BD. Okay, and that is how easy it is. Now, let's look at this one quickly. Let's assume that G1 is over here. There we go. And then we can also look at B2. Now please, this is not our theorem. Why not? Because even though they are subtended by DE and this one is on the circumference, this angle is not at the center and we're not allowed to assume it. Okay, so see you next time. Bye.